falls under each of these different bias and precision estimations. So there are closed versus open population models. A closed population model assumes there's no births, deaths, emigration, or immigration. The total number of individuals is not changing. And then populations may never truly be closed, but they may be close enough over short periods of time so you can use that as an assumption. If you're studying a very specific area, for example, and you know there's a population that moves in a particular valley, might be an example. Closed populations are used, models are used to estimate population size. In an open population model, it allows for births, deaths, immigration, and emigration. It's most useful for estimating survival rates. Some models also estimate population size, but these tend to have a fair amount of bias. So one estimator of a closed population is Lincoln-Peterson model. It's an early model that was applied to fish populations and waterfowl. So it's a two-occasion model. On the first occasion, a sample of N sub 1 animals is captured, marked, and released. The marked proportion of the population is N sub 1 over the larger N of the population. On the second occasion, N sub 2 are caught, of which M sub 2 are already marked. The marked proportion of the second sample is M sub 2, how many you captured that were already marked, over your N2, which is your occasion that you just sampled. So how many you sampled is on the bottom. On the top of this equation is how many had been recaptured previously from the previous effort. So then, assuming that the marked proportion is of the samples equal to the marked proportion in the population, suggests this formula, which yields the Lincoln-Peterson estimator of the population size. So then an example is given if the first time you sample 15, the second 20, and the second time 12 of the 20 are marked, then the estimation of the population given this formula is that there are 25 in the population. So this is an example of estimates from the Lincoln-Peterson model for humpback whales. And this was again done using photographs of their tails. So you can see the number, the 95% confidence interval gives you an idea of the population can range, even though it says in the first line 569, in the confidence interval you can see that's actually a range of 537 to 601, and you can see how the population fluctuated and increased over the last 2 years of this study up to roughly 800, 759. Multiple recapture models. Zoe Emily Schnabel extended two-occasion closed models to multiple occasions, and she developed the Schnabel estimate, which is a backbone of classical composed closed models while she was a grad student at the University of Wisconsin. And in this case, these multiple occasions, P was the probability of capture. So there are quite a few types of multiple recapture closed models that have been developed that have different assumptions regarding capture and recapture probabilities. These models use ML estimators. Every individual has the same capture probability on every capture occasion. So that's the one assumption. And that's not a likely scenario, but it's a good starting point for testing assumptions about capture probabilities. And then the other model here, the M sub T, capture probabilities can vary with time. Variation could be due to changing weather or changing effort. Past capture history does not influence current capture probability, and all individuals have the same probability of capture at each occasion. That's called the equal catchability assumption. And then here's the model sub B, is a behavioral response model, and it assumes that the probability of first capture differs from the probability of recapture. So the closed capture data assume that all survival probabilities are 1.0 across the short time intervals of the study. So therefore they're not used for survival estimates. The probability of the first capture and the probability of recapture are estimated along with the number of animals in the population. Animals can become trap shy or trap happy, so that's another confounding factor in these models. No individual heterogeneity. All animals have the same sort of trap response is an assumption. In the model M sub H, individual heterogeneity model assumes each individual might have a unique capture probability due to a combination of reasons, including sex, age, social dominance, and level of activity. However, individual capture probability is constant over trapping occasions, and that's assuming there's no trap response or time variation, and has been used for many species such as rabbits, skunks, and grizzly bears. An additional model includes combination of the assumption of the above models, which is the model M sub BH. So there are just multiple recapture models to be aware of. Open population models, the Jolly-Sieber serves as a starting point for open capture-recapture analysis. It assumes that animals are captured on multiple occasions over years, given unique marking during short tagging intervals, say a week, and animals do not lose that mark. Jolly-Sieber model allows for year-specific estimates of apparent survival, capture probability, population size, and number of new individuals entering the population. But it's not possible to separate survival from emigration or recruitment from immigration without additional data. So you don't actually know if individuals are successfully leaving or coming in to replace other animals without collecting additional data. And there's often substantial bias in estimates of population size and B, which is individuals entering the population. Key assumptions: it assumes that animals are randomly sampled from the population and that captures of marked and unmarked animals are equally probable. Hence, Jolly-Sieber model incorporates ratios of marked to unmarked animals and thus allows for estimates of population size. The Cormack-Jolly-Sieber model is about survival. It's a restricted version of Jolly-Sieber that is widely used. It's based on recaptures and allows only for estimation of apparent survival and recapture rate. Remember, 1 minus the symbol represents both animals that died and those that emigrated from the population. Does not assume equal catchabilities for marked and unmarked animals and thus does not estimate population size. Can be used for mark recite studies in which different methods are used for capture and for recapture. And here are some resources that may be helpful both for this lecture and for our exercise this week.